So this is a typical waveform we will usually see in engineering. And how do we get a mathematic equation or description of it. So this waveform AB, no, this 0 minus B, this x1, this B, right? Can be think as a superposition of equation of this form. Plus equation is x1 of this form. No, sorry, it should be yeah, this one. Okay, it's B 0. Right? If you add these two together, this is positive, right? It's negative. So add together will be this one. Okay? Yeah. But, and this one, okay, this one, and this one. This one is a portion of this equation we call the P1, P1x. Okay? If this x equal to 0. So this P1 equation, the line equation is equal to what? A over B, x plus B. All right? For x equal to minus b is equal to 0. For x equal to b, that will be 2a. 2a. So this is a 2 minus this 2a. So this equation I called function P2, P2x. And P2x will be v over 2a x minus. Right? This is the equation of this one. Then, here, for a function f x, and I only interested about the portion of it. This 2 points is equal to a, x equal to b. So how to write this part? Okay. So here I introduce the heavy side. Heavy side, right? Function. Or you could say unit step function. Hx minus a. It's like what? This is a. For x smaller than a equal to what? For x smaller than a equal to 0, right? For x larger than a equal to 1. So the function like this. Okay? Yeah. So this function can be written as this function fx function we times AV side yeah, heavy side x minus a. So that means this f function for x less than, I will get for this one and this one. So this blue one is fx heavy side x minus a. Okay? Right. And this part, I use a yellow, this part. This will be f function fx times heavy side x minus b. Right? For x less than b, I cut it. I times 0. Okay? So this, so this yellow part will be this part will heavy side, f x heavy side x minus a subtract fx heavy side x minus b. Okay? I cut this, so I only have this one. Where is dash? Okay, so this is this one. The blue part will cut by the yellow part, and only the red part remaining. So I can have any continuous function, I just chop part of it. I just use the heavy side function to write it. All right? So, this one, and this one will be what? Will be P1x times x minus heavy side x minus b minus heavy side x minus b. Okay? This x equal b. I only need this part. And this one will be what? So this one will be this part. Will P2x times heavy side x minus 0, right? And minus hx minus b. Okay? So this combination can give me of this shape. Okay? So this shape, this px, okay, equal to p1x plus p2x. And equal to P1x will be A over B, x plus B heavy side, x plus b minus h by x minus b. Okay, plus it's minus 2a over b x heavy side x minus heavy side x minus b. All right. My note seems I think it's wrong. I say x minus b. It's not right. Okay. Should be x minus b here. Yeah. All right. So now my solution will change everything to it. Put the x as x1 minus alpha t, and then another is x1 plus alpha t. Then you can get the answer. For this problem of half domain, half space problem, x1. Okay, and I have an initial displacement at here. I give a distribution something like this. Initial displacement. Okay, initial displacement at range, locally. Okay. Sorry. Initial condition is yeah, initial condition at along the boundary. Anyway, this is maybe it's not good problem. It's for here I said that x had a negative value has some value. But, yeah. Okay. So maybe this problem is initially it's a displacement. You can say this is a b, right? B, something like this. Okay, R0. Locally, initial. This is initial displacement. Yeah. Okay, so this is for initial displacement distribution like this. Here, I just want to show you some mathematics how to express this kind of a function. This is superimposed by these two. Okay, it's negative and positive, and each one is a piecewise curve. So piecewise curve, I can use a heavy side function to cut it from a continuous function by using heavy side function. Okay. Yeah. Now let's look at another problem for initial. Okay, let's plot the propagation. Yeah. So remember this, huh? For any continuous function fx, if I'm interested about the only part of it at a and b, I only want to get this curve. This will be fx times heavy side, x minus a minus heavy side, x minus b. This is what I want to know. Yeah. Right? Yeah. Then, for this propagation, because the answer is at time domain, okay, x1. Okay. For example, if I have a initial displacement at t, this is 0. Okay, I divide this shape into two waveforms. It's half. Okay, we have two waveforms overlap and got this waveform, right? And later on, at time t, okay, for example, at this time, it's x1. At t equal to T alpha t equal to 10. Okay, T means 10 over alpha. And this, okay, and this will be have this one move forward, have this height, and here to 10. Okay, it's 10, and that height will be this point about this height. This height, okay, and this is a this is a if this is 1, and this is a 0.5. Okay, so this is a 0.5. And if this is 60, okay. Anyway, yeah. Then half of it will be moved to here, and another half will move that way. So that means this one will move 10, and that will be something move 10, okay, forward, yeah, and in this end we'll have a 10 here, 10 here, something like this, okay. So one of this moved in this way, another this one moved in this way. All right, so the superimpose will be like this, okay, something like this. Okay, we'll add this here, right? You have to add together. Okay, the waveform will like this. Here. Something like this, superimposed waveform. Okay. Then you can draw at different time, maybe after some certain time. This one already moved to here, and this one maybe to here already. Okay, this one this way and this way. Okay. So this entire axis at different time axis is a waveform. Okay, and it's called propagation. Now, if all right, so this is an example for the. We assume the initial velocity is 0. We only know the initial displacement, and this is the answer. Okay, for the displacement. We have two signals, and half of a p, the signal, on that way, half a p, this way. Okay, so this is the answer. So this is initial, this is a p. is a P. Px initial displacement. Okay, and this is a half P. One half of the another one this way. Half. Okay. So this interpretation of propagation. Now let's see another case. We only have initial velocity. Let's see, n initial velocity distribution and resulting displacement distribution. Okay. In this case, for P1, for Px1 equal to 0, I mean no initial displacement. Okay. Then we only have the u1 x1t. Any point, any time, its displacement is only the other part, the x1 minus alpha t to x1 plus alpha t. This domain of dependence and its initial velocity distribution along in the domain, the x bar. We do this integration. Okay. So that's what I say. This is x1 axis, this t axis. For any point x1 at time t, right? So this is x1 and this time t. Its domain of dependence is like this. So this is alpha x plus alpha t, x1 minus alpha t. So this is a domain of dependence. So this is domain, right? Integration from here. I need information inside this domain. So this information, initial condition, at t equal to 0, will influence my result according to this equation.